Good evening, everyone. Welcome to tonight's webinar. I'm Ruth. I'll be the host in the background for tonight. I'll be monitoring some chat questions, comments. As we get ready to proceed with an exciting presentation from Travis, let's think about the chat window over there. If you don't have chat showing, down at the sort of the bottom of your screen, there's a floating toolbar, and there's a chat bubble. If you click on that, it will activate the chat panel over at the right. If you'd like to participate via the chat, be sure to select all participants from the drop-down menu. And if you want to practice that right now in the chat, choose all participants and give us a shout out from your location. Moving right on, Travis Bauer is our presenter tonight. Travis, I'll turn it over to you and let you tell us about yourself. And we'll keep an eye on those comments over in the chat to see where our viewers are from.
All righty. Hopefully you can hear me right now, and I'm going to attempt to share here. Clicking on there.
Good, Travis.
Okay, good.
Good sound. Anything we need to know about your bio there other than what we see on the screen?
No, probably not. Just right here, ready to go. And doing this, I'm trying to bring up my screen right here. Let's see if we have that. Are you seeing my iPad, social distancing?
Not quite yet. Have you
okay.
shared an app?
There we go. It should be coming up. Sometimes the speed of light's a little bit slow, you know? All right, so I assume that you are hearing my voice clearly. You might even be able to see my beautiful face down there. I thought we'd try something different where you can, good, thank you, Amber, where you can see the person presenting, give a little more action to it. Hear the crows in the background, reporting live from Santa Barbara, California here. And I've got this social distancing is what we've been asked to talk about. So my goals real briefly are going to be to present a math problem that, hopefully is kind of sparks your curiosity. There's a little bit of a hook there that gets you thinking about it. You can read what's happening there. We've got this long line, but what happens if they were to be put into in a rectangle and they had to have their umbrellas to kind of keep their 3-foot radius, to keep them spaced apart. So kind of have that visualization right there. And how many people could we get, say, some 90-foot by 150-foot parking lot? How many people, So that's kind of the hook to get them going. And then I might have the students work on this a little bit, and that's where they might cook it a little tiny bit. And then later we'll, with a class or with you, we would look at it. So I kind of have my hook, cook, and then take a look on that type of problem there. I also want to be doing not only the math, in which I'll call maybe the curriculum or the math, but I also want to be discussing some of the pedagogy that might be involved with this. You might just present this as a starter or a 10-minute problem, or you could even make it be a problem of the week, whatever you like to do on something like that. Have them in groups or working on it, all those types of things. Pedagogy is very important of how you want to present it. I like to have them do more thinking about it than I would do, but in our situation here, I might be doing more talking at the front end of this as we kind of guide you through. And then thirdly, I like to incorporate technology, and I love the Nspire platform. I used to work with the handhelds and Navigator. Our school has now gone one-to-one iPads, so we have those, and we have a pretty good architecture for the internet and the Wi-Fi, so we haven't had any problems with that. And I always like to answer your questions about the technology and things like that. So feel free to chat through there. Sometimes I might not see that, so Ruth will just interrupt, and that's totally fine. Remember, this seminar is for you, what we want to take a look at. So I'll be kind of looking down and looking up. We'll see how this works on the side right there. I'll let you know that on my desk right here, we've got some nice flowers, right, to set the mood, the ambiance as we're outside here. All right, so you've had a chance to look at that problem, and you could also scaffold it in the other direction by just making it in a line. You might just ask your students for a really easy one. There's 21 people out there, and they're supposed to be 6 feet apart. how long is the line going to go? You know, something like that, simple as easy as just doing it in a line, maybe in a sixth grade level or in middle school. And then you can go beyond that by having them be in a rectangle or maybe be in a circle or something like that, using their umbrellas as kind of that natural way of keeping them spaced. All righty. So let's take a look here. My screen just went to sleep on me. And I don't know, we might have beginners, we might have experienced users. So if I'm doing too much, you might tell someone in the chat, hey, he's going a little bit fast and I can slow down. Or, we know all this stuff. So I'll try to find a middle play through this. But over here we have the page sorter. And I love this right here. And you can see that yellow sun right there is show touch. That's something that you set up in the settings in Nspire. I also have this where you can see that's my zoom controller. That is something that I would use before TI gave me that sun, and I can use this to kind of point to things on my screen when I'm mirroring to a big TV screen, when you're using like Apple TV. So I love this ability to be able to point things out. Likewise, I can use the yellow one as well. So I've got 2 pointers. And if you put your 2 fingers on it, you get 2 suns and 3 and 4. And I've got 4 fingers on my screen. So, you can kind of think about some things you could do with that. So I like to kind of share some of these things as we go along that are kind of fun to be able to do. And this program is the Nspire app. There's the TI-Nspire handheld, the plastic calculator. And maybe you met what program. This right here is with the iPad in the settings called the Zoom controller and showing that controller. And then the yellow one is just show touch, all in the Nspire app for the iPad. All right, so these are some questions that, if a student might need help get going, if you're trying to orchestrate the conversation using the 5 steps of that, you might need to help some groups or get them kind of going and to think this through here. And kind of going to some pages. This was an attempt. I just wanted to show you what I tried to do. I thought I'd put on a grid, and you can see my circles are labeled, and they kind of pop around, and they don't, they kind of a little bit, kind of, it's not perfect, right? So if you wanted to have students save their work, this would be a great way to do it. Yeah, they're showing their steps. They're going, I don't like to call it my mistakes. I like to call it my attempts. So in mathematics, we want to have that kind of slow math mindset sometimes where we show our attempts. That's growth. And we have that mentality of a growth mindset. So I could turn off the labels. Notice I scaled my axes at 3. I can move that around, kind of draw your attention. So remember, students will look at things that move, and that draws their attention. But it can also be annoying. So I've got that. So that was just one of my attempts. Then I thought, well, what happens if I put the circles in hexagons? Because as a geometry teacher, I know that the hexagon, regular hexagon, can tessellate the plane. And so I thought, well, maybe I'll do that draw. It kind of messy to me, lots of dots going on, and, got different things, kind of messed up. But it's neat that when I made this, I started doing some reflection. And when I did that, it allowed everything to be attached together. So I kind of like that tool in the transformations that I had right there. So that was another one where I had the hexagons and circles. Notice that my circles are inside my hexagons because the hexagons are going to tessellate the plane. And if I have my circles go beyond, then, if I have the hexagon inscribed in the circle, it doesn't really model this that well. But I would let students make those discoveries themselves. I would let them figure that out as they go, and I wouldn't tell them right away. In our situation, we're a little bit constrained, and we want to distill it a bit. So we might make those things, I'd tell you about that. So now we're starting to get into where, you can see I spent a lot of time on this, right? What I've got there. And what I like about this is it's on a graphs page, and I'll point some things out to you. Notice that my scale down here on the y-axis is 3. When I have the yellow, it's grabbing the screen. But if I use my controller, it doesn't grab my screen. So that's why I like to have both tools. So that 3 right there, and then down below right here, that 5.2 is 3 root 3. I chose 3 because that's the radius. At first, when I did this problem, I had my radius at 6, thinking, you need 6 feet of social distance. And then I found out, well, that puts you at 12 feet apart. I guess that's safer, but they want at least 6. So I had to go back and kind of think that through on this. So what you can see on the side over here, I've got some numbers and some settings. I have the 24, and I use that 31.2, which is going over, that's how many square roots of 3 times 3 over that is. And this one is with the offset. Now, this is more advanced, and I just want to at least show you that, when you offset them there, it's very similar to a circle packing problem, but I don't think they're the same. So if someone looked this up, circle packing, I think the formula is a little bit different. And the reason why is because I believe, and I could be wrong, but I believe that a person could be standing in a corner, or like the corner of a parking lot, and then someone who is 6 feet away standing right there, and there. Those are not circles that are inside the rectangle. So in a circle packing problem, the circles would be inside the rectangle, but this is slightly different, isn't it? This is where the person could stand on the edge, and then they've got those umbrellas kind of poking out like that. So over on the side here, if it's 24 by 31, the smallest would be a 32 people, then 35 people, then 36 people, and then 40 people, depending on my dimensions. So by that I mean I've got right now that magenta rectangle is the smallest, and if I raise this up, then it goes to this one where the 27, I have the 27 value is this vertical, and you'll notice that I put the 27 on the side right there to let me know that that's the side of the rectangle. The 31.2 is this dimension going across there. And then if I make this be the 24, if I slide back down, but then move it over to right there, then I'm down at this 24 by the 36. And I know that because it says 36 up there, and it says 24 right there. So then I get 36. And I suppose I could go through and count these, but it'd be really boring for you guys to watch me count, 1, 2, 3, 4, 5, 6, like that. So I've already done the counting for you. You're welcome. And then on the last one is where I pop this up, and then it's the widest, biggest rectangle. So when I was trying to figure this out, I thought, I think there's 4 different possibilities that we have when we're trying to count. And that was due to, let's see, where'd my little controller go? Come on here. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So then I kind of paired these up and went 10, 20, 30, and 40. And that I got 4 situations how I was going to count when those circles in a hexagonal pattern, when they're offset, I had to kind of break it down into 4 different ways of looking at it. So that's a little bit more the advanced part of this problem, and that might be a project you'd give your students over a week or a month or something, or they could pair up, or however you want to do it. You could give them different dimensions. Tom Reardon had a great idea that he shared with me years ago when he was doing problem, and he knew the formula, so he had it all done in a spreadsheet. And then he would assign students, oh, you have a 27 by 36. You have a 50 by 84. And he would give all the different values to different students. Well, he had a spreadsheet, right, that had their names next to it and the dimensions, and he was able to calculate and know if they got it correct by just looking up their name, right? You could do a search and then see if their value was the same as his in his spreadsheet. Ingenious. I love that idea. So I pass that on to you guys for free. Maybe he'll even give you a test. All right. If any questions are popping up, certainly interrupt. I've been kind of talking nonstop for a little while here. I'm going to go through a little bit and show you some of the um, authoring of this. Right now is kind of the consuming of it. Are any questions popping up, Ruth?
I am keeping an eye on the chat, and I haven't seen questions yet. A couple of
Okay.
comments as you were getting started, but I think we're good. Thank you.
Okay. Great. So this one you can see this is much more refined, right, from my previous one. I mean that's pretty good, right? And then as I was working on this, I wanted to make it a little bit better and try to talk about those 4 different regions. So what I can do, and now I'm going to extol the virtues of our platform here. My magenta rectangle right in here, I can put a magenta dot right over here. So what I've done is I've just put a dot right there, and I put some text right next to it. I could have also put a dot right there and then labeled it with numbers, and then all the font would be in magenta color. So that's pretty clever, I thought. Hopefully that's worth the price of this webinar right there. These other ones here, the red was when it's going up. See, I can go, the magenta goes to the half of that circle, kind of right at the corner where the person's at the corner. For convenience, I always start a person in the lower left-hand corner. And then this person right here could be right there, and the magenta stops it, or it could have gone up to the top. And that's that red one right there. So what happens is when I go up to the top, I'm going to get some extra circles that'll be across there that I'll have to incorporate those numbers. And you can see the little values I've got, a little bit of pattern here. The 5 plus 4, the 5 plus 5, the 5 plus 4, the 5 plus 5. And then multiply by 3, multiply by 3, multiply by 4, multiply by 4. Add 5, add 5, add 0, add 0. So you have these different situations, what's going on. The way the blue should be interpreted would be if blue all the way across, and the brown is all the way to the left and all the way down. It's not just that little region right there. But if I did brown, it kind of overwrites everything that I had right there. So I thought I could show the 4 different areas there. Much like an area model, when we're teaching students how to multiply binomials or Punnett squares that we have in biology. This concept comes up quite often of being able to model what we're trying to show the students of what we've got there. So that was kind of my refined part of what I have, and you might want students to come up with something like that of what we've got there. All right, going to go through some of these. Incidentally, this will be available to you when they post the webinars on the TI site. I'll have this TNS, it's called .tns, that's the type of file format that the Nspire platform works from. Incidentally, this will also run on your desktop if you have the new premium software. Teachers can get a hold of that. And it can also run on the handheld. So all the files that are created with Nspire can go across the different platforms, which is just fabulous, right? A lot of people want to use their desktop. Some people want to do it on a Chromebook or whatever. Maybe only TI-84 is on a Chrome, or the iPads, what we've got there. Incidentally, not every feature is available on the iPad. There's more features on the premium software. So what I sometimes will do is I'll start it on the iPad, so that's its native environment. That's the country that it was born. And then I'll send it to my computer. Very easy to send, is an attachment to an email. Send it there. You can also put it on a website, my learning management system that I use for my students. And then I'll download it to my laptop, and then I can play with it right there. And for instance, one thing that I like is on the premium teacher software, they have the ability, I forget what they call it, teacher questions, kind of a dark red, chameleon color, and then you can make questions. Maybe it's orange. Anyway, maybe it's kind of orange color. And then you can make questions there, and then you send it back to your iPad. So some things like that. All right. So just know that, if you remembered something being able to do on the handheld or the software, and you can't do it on the iPad, there are ways to work around those situations. All right, so here, learn from your attempts. So this looks really pretty, doesn't it, right? And here's what I was talking about. There's a point that I labeled draft so that I can have colored font on my screen. If you don't like to see that point right there, if that bothers you, then you just go and choose that's such a tiny little point that you can't see it, but see it when I'm actually using an Apple pencil right here. Really nice on the iPad, and using this works really well to be able to use the iPad. So anyway, so if you don't like that, you can do that and you can kind of move it around, but I'm gonna go and do there. If I just can undo it a couple times and it'll bring that back to full size. All right, so just little things like that are kind of nice for you to know. All right, so when I was doing this, going like this, and I was all excited, and oh, I didn't like that, okay? Kind of annoyed me. So I called that one of my attempts, and I learned from that of how to get around that. It's probably when it's making my circles, it's kind of annoying to me when it's down here. It was doing that, so it didn't look pretty, and I'd move it up there, the circle disappeared, ran into some problems like that. Part of that is, what is that? Is that a point, or is that the polygon? Is that the circle? So sometimes you can click on that and change it so that it might behave the way you expect it to. So quite often, it's called engineers. The engineers at TI that make these, they do a great job, and I'll be like, hey, it doesn't work. Well, it's usually a user error. It does work. I just got to learn how to make it do what I want to do, or you've got layers on top of each other. So much like on the software, you can hit tab, kind of look through and look under things like that. All right, so I wasn't too happy with that one, and things got a little wonky out here. It wasn't quite all the tangents, but for a rough draft, it looks pretty good, and it gets the job done on things like that. All righty, so now I'm going to kind of go to, that was the more difficult part. Just want to show you it could be done. You might make this on paper, right, and draw little things, but after a while, it's nice to have technology so that you can refine it. Having to redo it on paper is endless, having to redraw all those things. Nice to have a template, right? Use a bottle cap. Hey, it's technology. But, I like to kind of level up a couple more than a bottle cap of doing that. So with the Cartesian lattice, and I don't know all the phrases, if it's the Cartesian lattice or it's the square version, I kind of made up this problem. I was just thinking, looking at the world around, it's like, what do you notice out there? Just look at a fence. What do you notice? Well, all the slats are right there. I'm looking at my back wall, it's a brick wall. They're kind of offset right there. And then the next one is, what do I wonder? What sort of rich mathematical problem could come out of something like that? So that's what I was thinking of with the social distancing. When I'm out running, I wear a mask, when I go by people, even on the trails, just for politeness, but I yell like, hi, because they can't see your smile. So I'm thinking about, what can I do with this social distancing? So I came up with this problem. So that's what I had on there. So on this one, I started off with a square, and it's much easier to do this with the lattice here, the square lattice, or the Cartesian system that we've got here instead of an isometric system. So,
Travis?
Yes, please.
Pardon me for interrupting.
No.
Sebastian is wondering, did you define the circles individually, or did you use a formula? So we can ferret out.
Yeah, great question.
Yeah.
So what's nice about this, and let me just start doing it right now, is when I made these circles, if I understand the question correctly, and you can clarify, I just used the circle tool on here under geometry, and I'm going through the menus right now, and that's because my brain is kind of with the handheld that we do right there, but I'll show you in a second a better way. So I've got my circle tool, and you can see it in the upper right, and it tells, tap the location. You get the tool tip, really nice to have right up there. And when I make a circle, I'll tap off to turn it off, tool tip, and if I make a circle, it makes my little circle right there, right? And I can kind of move it around, move the radius, and I can even move the entire circle. So it's kind of nice that I've got right there. So, well, what I did was I actually made the circles one at a time, and it gets really annoying if you do this, because now I have to go get that circle tool again. I'm kind of trying to undo it so it disappears. But if you go like this and you lock it, let me show you. With that lock, I don't know what the words are. I call it the persistent tool. You know, it persists. There's probably a fancy word that the engineers know. So now when I make my circles, you know, and I go over here and I say, all right, let's make a circle. All right, whoop, wrong place. I could undo that one. Make a circle, make a circle. See, I'm just kind of hopping across, right? That's good and bad. It's good because it's really fast, right? Just tap, 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 tap. But they can get a little bit wonky. So after you've done this, you might want to make a circle. And then, or when I was making the hexagons, then I just reflected. I reflected the hexagons moving across like that. So I'm going to try it. This is live now. I'm not sure. I never have reflected the circles. I'm not sure how they're going to reflect because it usually needs a line. But I'm going to do it, right? Because it's good for you to see the percenters and things have a growth mindset. So I'm going to go with reflection. And the tool says tap the line of reflection and then the object. So I'm not so sure if it's going to be, those are seagulls up above. Yeah, we live near the coast here. I'm not so sure how this is going to work, but I'm going to try it, okay? So here we go. Let's see what happens. Well, see that circle? I don't really have a line that I'm tapping across there. So not really working as well as I would like, and I might have to have my grid lines. So the circles don't really reflect very well. So maybe I could do, you know, a translation, and the tool says to tap the object, and then the vector. So I tap the object, and then you kind of need kind of a little vector, you know, that's going across. Well, that didn't go far enough. I wanted right there. So I'm not going to play with this too much, but you know, that I just tapped 2 spaces over, right? So that was kind of a smarter way to do it. But you just got to try things, you know. You try them and you see if they work out for you. And right there, we experimented with it, and reflection wasn't a good tool with the circle because it's got whatever infinite symmetricability, if that's a word, infinite symmetry. But the translation tool works a lot better for that one. So, all right, hopefully that helps Sebastian on that. And got this little rectangle tool, can move this all around that I've got there. And what I did was I started making the circles, and I realized I don't want to make all these circles. I'm just going to make dots, right? Because really this problem kind of distills into I don't need all those circles. I just need the points. And so that's what you see there. And I wanted to show you that if I go and if I were all the way at tools, and this is what I'm going to show you, you can just type in points, right? I love that search tool at the top there. So if you don't know where things are in the menu, and often the students, they don't. They just type in, you know, they remember, do it once or twice. You might show them and give them the words. The trickiest one, this is worth a little pez for you. When you're trying to find distance, use the word length. Write that down. When you find perimeter, use the word length because that's what it's under. All right, that one's free. So I'll go with point, and then, you know, you can just kind of lock it, right? And then you just tap on points. So you could actually be counting these as you're going. A little bit boring, right? But, you know, you could make a smaller rectangle, and you just, you know, put a bunch of those points on, or where people could be standing out in the parking lot. And you know that each one of those has a circle around it, looking like the circles over here on the left. Looking at like these circles right here, right? But you'll notice that I put too many, yeah? Right? Now this depends how you set your grid up. I set my grid up to have a scale of 3. So I'm kind of need to go every other lattice point there. Unless you were to make your lattice points be like 6, you know. So it depends how a student sets it up and how they're doing their counting. So I might want to go and get rid of some of those points. I believe I can just tap twice and then delete, you know, like that. And I better be careful which ones I get rid of right here. The problem when you're doing this 5 here, you got to think and present, and then I can slide that guy over. So I really don't even have to delete them, do it, right? I just need to kind of position them where they should be. And I'm not going to have any on there, and move them down here. So, I can kind of have those points and get them set up here. You can see that I'm just kind of moving them out of the way right here and making sure skip one. Probably have to skip that guy. There's not going to be any in that column. Anyway, you can see that you could set this up a little bit better than I've got right now and go across there, but you'd want to be a little bit careful when you got these and moving them. So I just like that. That's really neat that I can put the points there and move them around, make a mistake. Oh, sorry. I have an attempt, and I go and refine that attempt. Mathematicians, we never make mistakes. We just refine our attempts, right? That's the way we want to phrase it, a positive mindset of what we've got there. All right, so on the side right here, what I've done, this is text, and I've calculated it. I'll show you how to do that. And I decided that, I had 1, 2, 3, 4, 5 circles. But 1, 2, 3, 4, 1, 2, 3, 4. I wanted to say something different than I did. Oh yeah, sorry. All right. So I've got 1, 2, 3, 4, 5 circles, but the height of this guy, I'll put the coordinates on there. The height there is 24. So if the dimension was 24, and I divided by 6, 24 divided by 6, that would give me 4. So I would be tempted to think that there are 4 circles. But no, right? We've got that first one right there kind of locks down and you go up. It's much like when you ask students, hey, if you do problems 20 through 25, how many problems have you done? Well, I would say, well, 20 to 25, 25 minus 20 is 5. So I did 5 problems. But if you did problems 20 through 25, you've actually done 6 problems, right? 20, 21, 22, 26, you've done 6 problems. So it's always that tricky little offset that we often get in sequences when we're trying to do it. Are you starting from the 0th value? The n minus 1 and those things. So it crops up in math all the time. So it's just good to be aware of it. And we've got that already. So,
Travis.
Yes.
Is there ever a time where you would find it desirable to define those centers, those points, using coordinates or pairs in a list and spreadsheet or scatter plot or anything?
I didn't quite hear your question all the way, but I think it was something like putting in these values, the 30 and the 24, into a spreadsheet.
Would it ever be desirable, would it add to the lesson that you're doing to put the coordinates for the center points as coordinates in a spreadsheet, or data points for a scatter plot?
Yeah, it might be to set in other words, to make the grid, if that's what they're saying. Yeah, it could be, and then you could have those points be put into a list, and then use scatterplot to plot them out. Absolutely. I went from the approach that a student would be doing on paper, and then we want to refine that to use technology to do the paper. But that would be a great one if your students know how to do that, to put them into a matrix or an array, and then have those go into lists, and then have lists and the scatter plots go. Absolutely, and that's the multiple representations that we like to take a look. Yes, thank you.
Thank you.
I was going from the drawing because we can now draw on our screen. They say touch the math, right? I'm touching the math right here. I just think that's so wonderful that we have an app for Nspire. Been waiting for that, and it's absolutely fabulous. Okay, so then going down here, I kind of developed my formulas that I had here for a specific 30 by 24 or 24 by 30, however you want to say it. I'm doing this, and this is a calculation right here. It's a nice little tool that you type in text, and I will demonstrate that just briefly to show you what I mean by that, because it's so cool. If you forget where text is, remember you can just go to the tools and type in text. Oops, if I can spell. And there's text. And then now if I tap and I write 1 plus 1, and now it's just text. It has no soul. It's kind of mute. We need to wake it up to inspire it, breathe life into it. And the way we can do that is we can calculate that. So I go to my wrench, and if I didn't know that calculate was down here, and I often pause in class and let them see where I am, because they got to look up at the screen and they got to look down. So I always want to make sure I go at a good speed. Incidentally, it's a good time if I made someone else the presenter in class and they would mirror their iPad. And we can do that with Apple Classroom. And then their iPad is up there. And then I'm freed up to walk around untethered, and I can go help students. It slows me down. You can tell that I'm full of energy. I talk really fast, but I can slow down and walk around and let a student present that. All right, that's just a little aside. So I go to calculate, because I will remember the word. And the tool says, tap the expression to be calculated, then tap each value when prompted. That would be if you had some variables and things like that. So I'm going to see what happens if I tap it. Oh, lo and behold, it tells me that 1 plus 1 is equal to 2. So I can move that around, and if I highlight it, you can see that it's got little things. You can attach those just like you can on the handheld and getting those attached. All right, so I want to make sure you know about text on a screen, and it can do calculations. So you're not typing it in yourself. You just type in numbers and let the engine do all the work behind the Inspire. All righty, so that was kind of looking at that. I had been playing around with this, making the area of that magenta right there, that magenta rectangle. I like being able to have color so we can talk about it. You know, right now, I'm just talking out in air right now. And with modern technology, you guys are hearing me and seeing what I'm doing. You can sort of see my gestures, but you can't see me like touching unless we had like a little camera on it. So then what I do is I have to kind of move that around. There's that 720 right there. So you could reverse this problem and say, you had an area of 720. What might be the dimensions that people could be spaced out? And you can extend this problem to however it might suit your fancy. I'm not going to go through all this. I'll just kind of let you scan it, and that's what I talked about there. It has to do with factoring, and there's different ways to factor 720, divided by the 36 right there, and kind of worked it backwards. This is just me kind of playing around. Was there anything interesting down this rabbit hole? Was it kind of fun? And it kind of brought up the idea of when you have a parabola, vertical, y equals, it's a function, yeah? But when you reflect that across y equals x, and I hope it's the right direction. It might have to be this way. I don't know if this one's y equals x or y equals negative x. You'll have to tell me. So I'm holding up my left hand right now, and for me, it's y equals x, okay? But from your perspective, it might be different. When you reflect across that line and your parabola, when you reflect it, it doesn't turn, right? It does not turn. It reflects like that. So this finger here is on the left, and then it goes down like that. Well, this is no longer a function. Well, I think this is happening with this. When I give you the area of 720, and you try to undo it, it doesn't go perfectly back, like maybe a one-to-one function or something like that. So I just thought that was kind of fun to think about that. And, it's just kind of half-baked right now, but I just kind of put that out there. Again, we want to foster a growth mindset. Even as teachers, I like to convey, I don't know everything, and the students might find some really good materials looking on the internet or just their own brains. One thing I wanted to mention here, when I was doing the isometric or the hexagon or the offset version, whatever, this, and again, which I just love that I can kind of point and look at, this is a honeycomb, and I've got the hexagons so that the base is, the base on the bottom is parallel. And it could be turned so that the hexagons kind of point up and go vertical. This was kind of confusing for me because, I wasn't sure when I was making it, looking at the apothem and the radius of the hexagons. And when I scaled my x-axis to be in units of √3 and kind of worked through it, and I eventually found out the reason why is because I was going between having the circle on the inside of my hexagon or the circle on the outside of my hexagon. So eventually I had to settle that I want my circle on the inside, and then I want that way my hexagons can stack vertically, and my y-axis, just for convenience, all my circles would be tangent going vertically because the hexagons stacked on each other. So maybe a picture might be helpful in this. I've got one. Yeah, it's a little bit cluttered right in there, but I kind of looked at some of that. I'll show you how to scale that axis in just a moment right there. I've got some of those things like that. So if there's no questions coming right now, I'm just going to show you real simply how to scale those axes, and you see it down there at that 5.2. I'm going to go ahead and put some text on my screen with actions and text. And I like to do the menus because I'm using an Apple Pencil, and I just kind of tap, 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 tap. But if I had a keyboard, like my students have keyboards, they like to use, they'll just type out the word text, right? So it depends what tools you're using. So keep that in mind when you're doing this. So down here, I might want to put, my 3 root 3, and I've got that. And then, that's there. That's just kind of dumb text. It has no soul. But if I calculated it, then I would go to, remember, wrench. And it happens to be right here because my menu item, tools, was in the actions. So it's just there. And then tap it, and there it is, the 5.2 that I've got right there. Well, to get this to be 5.2, I don't have it as 5.2. No. I actually typed in 3 root 3. 3 root 3. And then I press enter, and it says it's 5.2. I think I can increase. No, I can't. Maybe I can. Sometimes when you have something on the screen that has a decimal, you can increase it. See that? See, I can increase the decimals on the calculated text value. And there might be a way to increase that 5.2 on the scale of the x-axis. Maybe someone will send me a comment of how to do that. Not a big deal, but you can see more decimals. So I don't want to type in 5.2. I want it as 3 root 3 and let, whatever it is, 14 decimal places to go out into the background right there. All right, I'm going to quickly go through some of these other slides here. I hope I've given you a little bit of how to author and to play around with these things. But I want to also make sure that you guys, if you have questions and things, that you'll be able to answer I'll be able to answer those for you. So looking across right here, note that we could write a program or a function. So the first one here is just a little function that I've got, and the formula looks complicated, but basically it's just taking the x coordinate in the upper right hand corner of your rectangle, dividing it by the diameter, and then you got to add that little 1 right there, because remember there's always one more. There's that one more that you have there with the counting. I chose to use the I part, and the I part is not an Apple product. It is the integer part of that. So when you divide, I might get a decimal right in here, as you can see. There's not. I don't want to have a decimal right there. So I ran it one time without that I part, and now when I run it with 32 and 26, 6 doesn't go in evenly to those values like it does to 30 and 24. Let me just go ahead and show you how to run this. And I need to go and find it. And this one is my function, and you see there's a difference between function and another one called that's a program. So I like these little functions. I used to be afraid of them, but they're just kind of fun. So if I type in 30 and then comma, these are I think these are I might want to call them parameters. I'm not sure. Get the words wrong right there. There's a special word for it. And then 3 is my radius, and it tells me, hey, you could make 30 people. 30 people could fit into a 30 by 24 using the square version that I got right there. I like that I can put over here a comment here, x and y are the dimensions that I got there. Remember the beauty of the function, it just returns a value. And you can put in the numbers that you want, and it returns a value. It returns a value. It returns a value. So you can multiply it by something. It returns a value. Okay? Whereas with a program, it's going to run through a program, and it doesn't return a single value. It's going to output different calculations, maybe I'll call them. So in this case, you can see over here my program. I have a request. I chose not to put them into the parentheses. I just wanted to let people know that I could have had them in as the, again, I hope I'm using the right word, little parameters right in there. Values that I put, input values might be a better word. Incidentally, on TI Codes, I think John Hanna was the author, I'm not sure, has a lot of great little tutorials that you go through, and I use those with my students. So I feel a little embarrassed that I've taught it and I do it, and these are the things I always have to review right before I do it. I forget those little words, the little details there that we've got there. But great, TI Codes and 10 Minutes of Coding, great resources that are available for you. So anyway, then I wrote M as the I part for the X and N right there. It just made it easier to fit. I could have put all of that formula down here, but it just didn't fit very nicely. So I decided to just assign the variable M and N, and then I put them right over there, and then it calculates. That's what I have there. So I'm going to go ahead and run this program right here. Let's see where I am here. It's kind of, come on. And the var, and then I go to run the actual program called Square, and I put the letter P after it, so I would know which one I was in because they kind of look the same. And I'm just going to press Enter, right? And it pops up, hey, dimension of 33, and because I've run it before, it could have been 34 or whatever it is. I hit the OK. And then 26, I'll leave that one. And I chose to put the radius in there. I could have left it out and just assumed that this whole thing was a radius of 3. But hey, the governor might decide, nope, 6 feet is not enough. We got to go to, 6.4 feet, and then I could change my radius, right? So I'm adaptable, right? I'm going to mess around. All right, hey, look at that. Tells me that 30 people can fit in. And that's why I had to do that I part that I had there. At first, I just made it so that every dimension were multiples of 6 and things like that. All right, moving along here. Here's on a notes page, and I can increase the font, which is wonderful. Don't forget that. You can increase your font so that if you got students in the back of the room, they can't see it. You can also have your zoom setting here, and you can do that as well, right? That's an Apple product that you can do. So if students can't read something, and it happens all the time, I just zoom in on it, especially the graph entry line when you're graphing something. All right, so that's just the formula there on a notes page. You might want to start here as making just your formula in a notes page. Really good to start off programming here. Don't tell them they're programming coding until after they've done it, and then say, hey, you just programmed. You just told that computer, that Nspire, to be able to be adaptable, and these things automatically update. Just go back and edit that, make that be 29 what it is. And didn't change it there until I kick it up a little bit more to maybe 30, and then it's going to do it, and that changes to 42. So I love this. It's immediate feedback for the students. They get to see the code, and it happens. But after a while, they might want to be more sophisticated and say, hey, you've already coded with a math box, you guys. So maybe let's go and do it on a spreadsheet. And so I've done it already for you here, and get this little guy so I can show you. You can see that I used XX. I like to use 2 letters so it doesn't think it's a column. You can use names, like I use people right there. So I could have used the horizontal or the vertical or the X dimension, things like that. And then you put in values here. And then I just coded this right up here. I just had to write equal the I part of the XX. The apostrophe, I think, is just because that variable was made in the spreadsheet environment. So I just tell the students, just ignore that. It's just like British English and American English. We can understand. And then I multiply by the other one. And, I have done this and forgot the little +1. Your students will do that also. And then you'll notice that when this one had a decimal, this one had a decimal right there. The one drawback of doing this is if I go down here and I type in a value, double tap, and I type in, like 8 and press an enter, it gives me dimension mismatch. So I just tell them, don't worry about it. Just hit OK. And you just got to put in its cohort on the other side right there. So I go and put in here, come on, keyboard wasn't working, if I put in 10, and now it's going to work. It all goes to good. So one thing you can do is just fill up numbers kind of first, is just tell them, well, just go back and edit. And then that way, when you've got 45 right here, it never makes an error now, right? Because 87, it just calculates it right there. It's when you're out of the column there, when you go to a new value, it gives you that error. Not a big deal. I tell them, hey, you're not a real programmer until you get a couple syntax errors. So that was on the spreadsheet, and someone had kind of mentioned using the scatter plot. Well, this is where you'd put in very easily, put in some values into a column, and then those could be plotted on a screen to be able to plot your dots on here. I use the spreadsheet to be able to calculate the number of people, but you could definitely, with some creative thinking, be able to put those and put them in here, and then it just makes the dots on your screen. I'm thinking right now I want to do that from, to go level up on this presentation. I'll be able to do that on the next one. All right. Here's some related topics. I told you that I don't think this is circle packing. I could be wrong. I think this is circle packing. I got this for the web, and the blue ones are spaced out with that kind of √3, and the red ones are just by the radius of the circle. Here's that offset. I was able to put a picture in here. I got thinking, on the flag, is the flag, modeling this? And it kind of is, and it kind of isn't. When I look at those stars there, I kind of see diamonds, or I see, groups of pentagon patterns. I don't really see hexagons. You either have to ignore the ones on the top or on the side. So you can think about that at your leisure. Here I was playing around. I introduced some graph paper, some isometric dot paper onto there. You can maybe do something like that. And then the kids can draw on it, using the segment tool and just going like that, and, making things that you could have right there. I don't like the resolution, so I'd probably have to get some better ones or just make my own. I just grabbed a picture from the web and pasted it in there. Here was showing some work that I did, on paper. I like to work on paper, kind of move all around. It's a great tool. Papyrus is technology, right? So I use that tech when it's good there. And you can see a little drawings. It gets all crazy. And then after I've done that, then I can refine it and put it into, the tablet form. I might go straight to the iPad, but I also might want to have it on the side. I don't think any one tool is the best tool to be able to use. I like to use both. But if I was presenting this, and I was talking about this paper, and I said, look over here, we could do that, right? And I can script on here, but it's a lot nicer to have it all kind of clean. One more thing I want to show you and not to get interrupted is if I added I'll add a clean geometry page. I've got this tool here called MathDraw. This was found in Tools and MathDraw. Look at this. This is pretty cool, right? You can just draw. It disappears or it goes into makes a shape. So there's certain shapes that it knows to be able to do. So keep that in mind, that if you want more than the yellow sun and you want more than this, so this one doesn't leave a trail, but if you like to kind of draw and have things and show students, all right, we're going to go to A and then we're going to go to B, and you have that drawing, when I lift my pen, it's going to just disappear like that, right? And it can kind of erase things and draw things. So know this MathDraw is a real cool feature on the Nspire app for the iPad. All righty, I think that's about it for me. We always like to start on time and end on time. This will be up, and Ruth, if you've got any closing comments or if there was any questions, thank you guys for attending using your I guess it's not summer, is it? Your stay at home. I'm teaching from home right now. making videos and Zooming, all sorts of things like that. So thank you very much for attending. Hopefully you gained a level up.
Thank you, Travis. In the chat, I've sent out an opportunity for you to ask some questions of Travis if you'd like. I'm also going to put in the chat the link to your certificate of attendance. It's showing on the screen there. It is also in your chat. You can copy, paste from there. Okay. Travis, would you like to put your contact information in the chat, maybe?
Yes, I can, and it will be in the very first page of the document, but let me just put it in right now. It is tbauer at SBUnified, if I can spell, I'll look at my screen right here, tbauer at sbunified.org. Yeah, that's it. So Travis Bauer, tbauer, and then SB for Santa Barbara, and then unified.org is contact. Please send me an email, anything. If you got any suggestions for improvements, or you just want to give me a attaboy and thank you for what I've done here, or if you got any ideas we could go beyond this, or you find a cool link on the web that you find, this connectivity with each other is especially wonderful and important during this time of social distancing and things like that. So don't hesitate to email me, today, tomorrow, in a month, no problem.
Great, thank you. Also, you're seeing on a slide there that the free download of the Inspire app for iPad, Inspire Cast app, has been extended through May 2020. Okay. In the documents for tonight's webinar, you'll get the TNS file that Travis shared during his session. You'll also get slides, so you'll have this information coming to you. You'll get an email, and it will let you connect to this and download some files. Okay. Got a certificate of attendance. Travis has shared his contact info. Right after this, you'll have a survey that'll pop up on your screen. If you have a chance, that'd be great to follow up with that. 1-800-TI-CARES, and then technical questions. There's the phone number. Again, you'll be getting these slides if you want to download them, along with this TNS file, anything related to what we've been doing tonight. Next week, another round of 2020 T³IC virtual sessions. Okay, you've registered for this one tonight, so you know where to go to find out more. Going to give one last look up and down the chat, see if we have any more questions. Travis, thank you so much for sharing these.
Welcome.
Giving us a lot to think about tonight with the file, and we look forward to seeing that TNS file.
Yep.
And a reminder, this session is recorded, so if you want to go back and look at some of the ideas that Travis shared with us, maybe once you've had a chance to download and explore that TNS file yourself, you can go back and revisit it. Okay, keeping an eye here, see if there's any questions popping up we need to attend to. Righty. Keep in touch, folks. Stay safe. Thanks, everybody.
Bye, everybody. Thanks.